Hey, good afternoon, everyone. Um, uh, I'm Vivek Gupta, and I represent Benison Technologies. And I'm here to talk about the challenges we faced while building various DPDK-based applications. Okay, and here, why we want to highlight this is that while as a business, we work with various customers and who ask us to migrate a lot of applications from the standard Linux applications to DPDK or VPP. And while we do that, we face a lot of issues and challenges, and we wanted to raise them in front of the community and see if something can be done better to that, and if any help needed, we will willing to do that. Okay. So as part of the talk, I'll talk about the general introduction, what the problem is, why we want to talk about this. Then we would like to classify the applications into various types, right? What are the different types of user applications are. And this is not a complete classification, but the applications with which we are dealing. It doesn't, by no means, a complete classification of applications, right? And what we also want to highlight is that when we were building these solutions or applications, what kind of challenges we found we faced, and then how we solved them, right? But at the same time, we do feel that they are not the completely right solutions. There can be much better solutions than them, which can be more useful in a generic form to everyone. Right? So we want to highlight those, and then from there we want to consider about what can be the next steps to make it happen. Okay. So the problem statement, what I want to highlight is that as we have been discussing here the whole sessions, and in general, there have been tremendous improvements have been done and are being done to improve the I/O, the packet throughput, the infrastructure. But at the same time, I feel that at an application level, a lot of things, they get ignored. Although the applications, they do get the benefit of the inherent infrastructure improvement, no doubt about it. But in some cases, that benefit doesn't reach till the applications because of some overheads which lie around, and they don't get solved. Okay, and so in that part only we want to just figure out what we can do to solve these problems, right? So this is exactly what I talked about. We have high-end CPUs, we have high-speed memory, accelerated I/Os, like a lot of offloads, but unfortunately, a lot of benefits, they don't reach to the application. Right? So this is exactly what I wanted to say. When our customers come to us, right, or in general, the challenges are people want to migrate standard Linux user space applications to DPDK and VPP. And the key factor is that everywhere the demands for bandwidth and the throughput scale are increasing. And the perception is that if you move to DPDK, VPP, overall the scaling will improve, right? But it's only half of the picture. At the same time, other challenge which happens is that nobody wants to rewrite the applications. They want to ensure that the applications remain the way they are, or very minimal changes, of course, in that, and then do it. Now, we can always argue that this is a wrong expectation, but in general, that is what it happens, because nobody wants to retest the whole thing. And then when the application matures, everybody has done a lot of changes, quicks to make it happen compatible with every versions, different things. So changing the applications many times are not an easy option. And of course, everybody also has a time to market challenge, right? So once it all comes, on one end, what happens is that you want to migrate your applications to a 10x, 20x kind of throughputs. At the same time, nobody wants to rewrite the applications, right? And so what happens is in this, you end up doing some compromises. Okay, if not 10x, can I do with 10x, like 5x throughput improvement or something else, so that I can get at least better than what we are, right? And all that actually reduces the impact of the gains which would have been made in the user world networking, right? And the second thing is like, while we are making all these improvements, what also happens is the bandwidth requirements at the edge side are increasing a lot, of course. And then the equipments which are at the edge side, they are typically very low-end equipments. They don't have so much high resources or through power where they can get the kind of throughput they need, or they can dedicate so many cores for certain operations. They are limited with the hardware. The cost of those devices is limited, right? But the key challenge again comes is that for every company or every OEMs, when they have different models based on their capacity, everybody wants to keep the software same, right? So that they don't have to test it again and again on different ones. But I cannot have the same software which has on a CPU which has just 2 cores with respect to 20 cores, right? I mean, many times the kind of scaling you need, especially with the DPDK, VPP kind of applications, they need dedicated cores for a lot of things, right? So these are the few things which I want to highlight here and discuss on those. Right? The first thing, we'll talk about the classification of various apps. And as I said, this classification is by no means a complete. It is just about the applications which we have been dealing with, right? So when we say this, there are a lot of high throughput applications which are TCP UDP socket driven, right? And people do a lot of, some examples can be web servers, they can be secure gateways, they can be the things which do need these kind of supports, right? Similarly, SSL is now almost prevalent everywhere, and any applications which deal with SSL needs to be accelerated, right? But unfortunately, SSL, although it's quite prevalent, but it still takes a lot of locks in its operations, right? So once it does that, it becomes like all the benefits which you have been talking about, they suddenly get nullified, right? Now, there are a lot of machine learning solutions which are being developed, which are being used to derive at zero-day malware detections, which we are working on. There also I will try to highlight what we have been doing. And then there's some observability apps on those. Because of the limited time, I'll not go into the details of those, but yes, I'll cover a few aspects of these applications. Right. So when any TCP UDP-based application runs, right, key things which you can broadly classify the TCP UDP-based applications into 3 different parts. They can either be event-driven applications, where they get certain events, and with those events they take the actions, right? And most of the times the applications, they end up making blocking calls here. They make blocking read-write operations, and sometimes different else, and then and sometimes they also do async operations which do it, but many times for any complex needs, they kind of do the blocking operations, because async means a lot of state machines have to be written. Right? Now, when they want to scale these applications, what they do is they kind of run multiple instances of those applications, and the kernel by default, it runs an RSS, so the packets get distributed across the different instances of those applications. Right? Now, other thing is, other model which applications follow is a thread per connection approach. So anytime a new connection is being made, it spawns a thread. Now, if it does that, it is almost very, very contrary to the model which DPDK takes, right? DPDK or VPP takes, right? Very standard web servers, for example, Apache itself, it takes this model. Anytime a connection happens, you spawn a thread work on it. And it's a very prevalent model across the industry, right? And the other model which is common is a worker thread model. And that worker thread model is where you have certain threads which are actually doing the I/O part, and then you give the work to various worker threads, which then kind of do the whole processing, right, and then do the work back. Okay. Now, The key difference, I'll come to that. So in DPDK, there are DPDK-based user-space TCP stacks, which have been developed. Now, those stacks, to a certain extent, they're quite good, none about that, but they also have certain limitations. Now, if you want to do those limitations become quite prevalent and are quite blocking to make things happen. Similarly, VPP host stack, right? It is quite good and quite good performance it gives as compared to the Linux, but it also has limitations that if you want to use it, either you have to write the application the way VPP wants it, and that's almost like a rewriting an application and not really a real option. The other option is you can integrate via MMF or the libvcls, and if you do that, it requires a copy. So if I do the copy, I've already lost the advantage of using a VPP to a certain extent. Although VPP is still very good as compared to Linux, it still gives a lot of improvements. But still, if I end up doing the copy, then to a great extent, the point gets muted. Right? So this is basically the way how most of the DPDK-based TCP stack architectures are, or how they work. Most of the times, many stacks, which are open source stacks, they work on a per process model. Okay, so what they do is anytime traffic comes, so this whole processing is happening in the context of the same run to completion model. What means you receive the packet, you're doing the DPDK processing, then you're passing the packet to the FreeBSD stack. FreeBSD stack, I mean, because most of the user space TCP stacks are done by porting FreeBSD into the user space. So then when you receive the packet, you do your regular RX bus, you do your packet parsing, then you give it to the FreeBSD. Once you give to the FreeBSD, you give to the socket, and from the socket, it is given to the app. And now from the app, the processing starts, correct? And many of those, they don't support even the thread model. They support a process model. Now, if we do this in the whole context, if the application is it's a heavy-duty application, then the whole processing just doesn't work. The amount of activity which needs to be done here is too much. And especially when you talk about the applications which are like the VPN gateways, secure gateways, where you have to do things. So you end up doing the encryption, decryptions, and then the policy lookups, do a bunch of things. It doesn't work well, right? So it does serve to a certain category of applications, but somewhere there are limitations which needs to be handled, right? So this is what I wanted to say with the above models. If the applications wanted to do some heavy-duty processing, like policy lookups, deep packet inspections, they end up facing a lot of issues, right? The packet says high latencies, frequent packet drops, multiple retransmissions, and whatnot. So based on this, right, I'll just take one sample application which we had worked on and our customer wanted to solve it, right? So basically, it was a proprietary application which was implemented in a secure gateway product and implements a server per thread connection. And they also had a mix of sync and async operations, which was done to improve the throughputs. And it requires per packet decryption as well as the ACLs. Now, the key thing here is because the secure gateway product at the NIC level, you receive an encrypted packet, right? And the thing to do is you decrypt the packet, and after that you remove the encapsulations, and then you receive the actual packet on which you want to apply the policies or you want to do things, right? Now, once that happens, kind of offloads which you want to use are not applicable. Right? It all has to be done in the application in terms of your own flow tables, your own session management, your own aging, everything. Right? Now, scaling the system, they were kind of scaling here with the running multiple instances of the same process, and that helped in kind of getting the multiple, the connection setup rate improved for them. But yes, still, after this, the next step for them was to move to DPDK kind of behavior, right? And they also had to deal with the authentications here for each user. So the way kind of made the solution work was to split the application into two different parts. We made it as a slow path and a fast path application. We had split the cores also into two. One was the packet processing core, some of the worker cores. And the packet processing cores are doing the packet I/O using the socket calls. And they were also doing the packet parsing. They're doing the session lookups and determine whether the packet belongs to the slow path and the fast path. Now, here, most of these stacks, they have a problem that you cannot use the socket from any other thread apart from the thread it is binded to. So if you want to offload the processing, so then you have to bring the response, and if you want to send the response back, you have to bring back the response to the same thread, and from there you can transmit. So that something is again an overhead. Now, so that's why what we did was we splitted the application in such a way that the slow path activities which required packet processing, those also handled in the same core, but the activities which required no packet processing per se, for example, policy lookups, ACL lookups, we could do in the worker threads, right? But anything which is related to authentication, which is related to something where you have to contact further servers, do further communications, they were done in the same context, right? So this is the kind of architecture we kind of came up with. So here we used the DPDK again and the user stack, but in the app, as I said, we made the parser and the fast path processing and the partial slow path. And also all these processes were connected via the rings. And when they were connected via the rings, so certain path of the application processing of the slow path was handled in this code, right? And that's how we were able to achieve, and this kind of works well. But the issue what happens is, what happens is that we end up changing the application a lot because we had to do these async operations. And once we did that, now, and we made these operations, the kind of challenges we face is the application functionality breaks. At the same time, so of course we had to fix it. We fixed that. At the same time, with these things, the key challenges happens in terms of the corruptions or the memory problems or the behavior at the scale and performance, because we are doing these operations which otherwise won't happen. So those were fixed, but all I'm saying is these could have been much better and easier if the support was much better for the infrastructure, right? So this is effectively the key takeaways is what I'm saying is simply what I've been telling, that we can do the solutions which we did, they worked, but they were not the ideal solutions. Had it been like a much better support available, we could have done a much better job here, right? Now, similarly, we want to move to the like SSL VPN-based applications, right? Here, again, SSL is a very, it's almost everywhere in every communication that is being used. And the customer was trying to build an application which was like a broker, right? So what it means is, on one side you have huge number of remote users, and on the other side you have data centers. So the remote users are trying to connect to the data center applications, and they wanted to patch the things together, right? Now, the key challenge is, on one side you have a highway, and on the other side you have very narrow path, right? So there can be thousands of users, but each having a narrow bandwidth, and on the other side there are limited servers, but they have a very high-end bandwidth, right? And for each connection, you require two tunnels. First, the packet is coming in from the user space to the broker, and then from the broker it is going out to the data center, which is second tunnel, right? So per packet there is a cost of encryption and decryption and then an encryption. So again, here the application which we used here, that again had it was also using a thread per connection model. it was, and as I said, at many places it uses the sync processing model, and the extensive locking was deployed in the application to make it work, right? But of course, this cannot scale. Now, so this is effectively the model of the application was, where it was having a socket, and then the threads, it could use up to n number of threads for as many number of connections. Right? Now, the way we changed here was that because we end up choosing the model like this here. Now, here, the model was basically, we used VPP as our host stack, okay, and used VCL to integrate with it. And the key thing was, each core packet and each core, there were too much of activity to be done. And we were offloading completely the TCP processing over here. And with this processing, we were able to do the SSL encryption, decryption, and the fast path, of course. And the shaping requirements were also pretty, it's not a standard shaping, although I've named the term as shaping. But what it means was that from one side, you're getting a traffic which is very high end, but you're giving it to the side which is low end traffic. So when you're downloading something from a server can transmit data, for example, at 100 Mbps. But the remote user connection can be, let's say, 20 Mbps, 25 Mbps, right? So, but the number of such connections can be very high. So there can be up to 5,000 tunnels, 10,000 tunnels, the users which are connected. But the data center applications are maybe just 100. So the amount of traffic which can be coming from the servers but has to be managed is like a different problem statement here. So this is what we kind of tried to do. And then here again, as I said, so we were kind of able to achieve the end objectives. We were able to do the slow path and fast path processing so that we don't have too many overheads, and we use VPP VCL to make it happen. But as I said, we compromised on the packet copy here. If this packet copy was not there, my performance would have been much, much better than what we had till now, right? So this kind of thing, if we can enhance it, and in the VPP, we can make applications be a bit easier to move, then things can be very, very different. Right? I'm running out of time, but I'll just quickly. Okay. Yeah. Okay, fine. I'll stop. Yeah. Okay.
Yeah, thanks a lot, Vivek, and apologies for stopping in between. I think.
No, it's fine. It's understandable.
Yeah. Yeah, thanks a lot for a presentation.
Any questions?
Yeah. I think we probably had to.
Hopefully a quick one, but you never know. So from what you've talked here, you've talked a lot about changing the applications to make them work with DPDK and with the stacks and all. But is there any brief or quick asks that you would have of DPDK community for changes that would make your life easier in doing this work? So briefly, what are the one or two things that would changes to DPDK that would really help in this kind of situation?
Yeah. So basically, the key thing here is that now we can argue whether it lies in the DPDK domain or not, but in general, from the application's point of view, these are needed. So for example, enhancing the user space TCP stacks. They said they should enable the usage of the same socket from different threads. They should enable the sync operations. And I understand the issue behind that, where why it is being modeled as an async. But there can be some enhancements on there in terms of the microschedulers or something which can make things work in that fashion. But this can really help a lot in terms of moving the application smoothly, right? Similarly, the session tables, staging and session export. Now, this is a problem which almost every application has to do, right? Every application has to manage the session tables, and also with unfortunately, DPDK supports it with the RT flows, but those are at a NIC level, but when the packets are complete in the plain text. right? But here, the packets are completely encrypted, and you come to know about the packet only when it's decrypted. So you really have to, all the applications have to manage their own sessions and do it. So this kind of framework can also help a lot in migrating applications very smoothly. Right? Similarly, like there's an OpenSSL equivalent of DPDK that can help a lot because, as I said, the DPDK takes a lot of locks. Sorry, the OpenSSL takes a lot of locks. Now, that kind of negates the whole benefit. And writing OpenSSL is a thing which, of course, it needs a lot of effort from everyone. Right? And the other part was the traffic management, where I talked about like the traffic coming from one street to other direction. It is not shaping, but I was just making it a team like a behavior of shaping. And I believe a lot of gateway applications, they need this. Right? Yeah. So this was the thing. And
Thanks.